My name is Hirobumi Saito, Japan, and today I will talk on our demonstration experiment of 2 to 3 gigabit per second X-band radio wave downlink communication from low Earth orbit small satellite. This slide shows the recent radio data downlink of Earth observation satellite. So I show some table of the radio wave data downlink situation, and the large Earth observation satellite has the capability of 1 gigabps or something like that in X band. And last year, the Planet Lab, Dove, presented the paper of the 1.6 gigabit per second X band downlink in this conference. Probably this is the highest downlink speed recently. But this year, we renewed the highest 3.3 gigabit per second downlink as a demonstration experiment, not operational one. And the National Space Agency, like NASA or JAXA or DLR, use 26 gigahertz K band, achieving higher than 4 gigabit per second in 2020s. Probably in 2 years, the Ka band downlink will be realized. And also, non-geo communication constellation mission will use Ka band. So now the legacy X band versus new frontier Ka band is appearing in the the satellite communication field, and also CubeSat application will be important. And this slide showed how to increase data rate under frequency band limitation. And frequency bandwidth delta F equal to some symbol rate times a kind of filter factor. And uncoded data rate is symbol rate times modulation order K times polarization multiplexing P. And here the modulation order K is, these example. In case of QPSK, K equal 2, and in case of 8PSK modulation, K equals 3. And in our 64 APSK modulation, K is 6, and 256 APSK, K equals 8. So one symbol can send case bit. So we can use the bandwidth very effectively. And in addition to such a modulation scheme, we can use polarization channel, P equal 1 or 2, the right-hand circular polarization wave or left-hand circular polarization wave. So we can make the bit rate double. So in such a policy, we have developed 2 to 3 gigabps X-band downlink system. And so we developed onboard X-band transmitter and also onboard antenna with dual polarization antenna capability. And we put these X-band onboard system on the Japanese JAXA small demonstration satellite RAPIS-1 in last year, and we received our signal at the JAXA Usuda 10-meter ground station. That station is modified from original cable band to X in this project. And since there is no such high bitrate demodulator in the market, we record that signal in the ground data recorder. And after the satellite pass, the software demodulate that signal, and we merged two channel signal to realize the one very high bitrate channel. The left shows the downlink system parameter. And so experimental was done in last year and to the beginning of this year. I will show the several experimental data. This slide shows the 64 APSK bitrate is 2.65 gigabps downlink experiment. This graph is as a function of elevation angle. So we plot signal to interference plus noise power ratio, SINR, by solid line, and also frame error rate, also solid line with triangle, and the error vector magnitude with minus sign, EVM, minus EVM, and also XPD, cross polarization discrimination by cross line, cross mark. And at elevation 18 degree, SINR is 22 decibel, and the error free is confirmed by software demodulation. And then higher elevation angle, SINR increase, and then we continuously demodulated 2.65 gigabps downlink. And at low elevation angle, signal is low and Doppler change rate is slow. But however, at high elevation angle, signal is high and Doppler change rate is fast. So software demodulator needs parameter tuning to take balance between the signal to noise ratio and frequency change rate. And this slide showed the IQ constellation of demodulated signal on ground. Upper line is 24 APSK modulation, and lower is 256 APSK modulation. And left is left-handed circular polarization channel, and right is right-handed circular polarization channel. So simultaneously, we used two channels. And as you see, especially 256 APSK, constellation point is very dense, very hard to distinguish. So we must keep well-aligned constellations in link channel. So this research pays much attention to 3 points. One is nonlinear distortion of transmitter power amplifier, suppression of these nonlinear distortion, and second is suppression of crosstalk in antenna, ground antenna and the onboard antenna. Third technology point is Doppler shift correction in software demodulator. So due to this kind of technologies, we successfully performed the, the 256 APSK dual channel communication. And another one point is our dual polarization channels. So we utilize two polarization channels, but unfortunately there is cross polarization interference in the channel. At the transmitter antenna or at atmosphere due to cloud, rain, and ice. And also at the receiving antenna, the two polarization may mix. And such a cross polarization interference is described by XPD, cross polarization discrimination, defined by this equation. Main signal power versus cross polarization interference. So concerning the atmosphere XPD, ITU, International Telecommunication Union, proposed a model of XPD atmosphere due to cloud, ice, and rain. And concerning the antenna polarization, XPD, we have developed excellent septum type polarizer for onboard and ground antenna, which has very high XPD polarization discrimination, higher than 37 decibel. This picture shows the onboard antenna with this polarizer. This graph shows XPD as a function of elevation. Dotted line shows the ITU model of atmosphere XPD. As elevation increase, XPD increase. And broken line shows a limitation of hardware antenna XPD. So the end solid circle is a measured value. So at low elevation, atmosphere XPD is dominant, but as elevation increase, gradually XPD improved and then saturated by the hardware limitation. So since we have developed very good septum type polarizer, we can achieve the 32 decibel XPD at elevation 30 degree and 34 decibel XPD at 60 degree elevation. So this is key point of this two-channel polarization system. And this slide shows a conclusion. We demonstrate high-speed data downlink in X-band from small satellite. Symbol rate is 300 megasymbol per second and 64 APSK times 2 polarization. The data rate is 2.65 gigabps and frequency utilization efficiency is 8.4 bit per second per hertz. This value is quite high value. And also we have a good, very high data rate, 3.3 gigabps with 256 APSK dual channel. Probably they are the highest speed link, but this is not operational system and not real-time demodulation system. And the key technology is nonlinear distortion of RF power amplifier and cross-polarization interference and Doppler correction in the modulator. This is a future of a glass slide. And for small satellite constellation mission, we have to use a little bit smaller ground antenna, 4-meter ground antenna, or practical room temperature low noise amplifier, and small patch onboard antenna. Probably in that case, we can realize 2 gigabps downlink system using these technologies. So, and onboard transmitter will be or should be the size of CubeSat, like Dove Planet Laboratory. And fourth, also inexpensive real-time demodulator is being developed. And better to have compatible system for X and Ka band, replacing frequency conversion part. Thank you very much. That's all of my talk.